Okay, in this project, we are going to make a simple virtual makeup program written in Python, where we are going to take an image and we are going to apply our virtual uh, makeup. As you can see here, we will take this original image and we will apply some eye lines on here, and also we will change the color of the lips. Okay, so to do that, we are going to use first of all OpenCV, and we are also to use the linear algebra library in Python, which is called NumPy. We are going to plot everything using Matplotlib, and we are use the library dlib just to detect the face landmarks. This is a very standard library and is part of iOS, so it's used on mobiles and is very quick and allow us to detect landmarks and faces on images. Okay, and we are going to have also a helper function that will allow us to plot the points of the landmark detector. Okay, so the next thing is just configuration of the matplotlib in terms of size, the color map, and the interpolation, just to fit the image into this size. So it's a common procedure. Okay, and we will start using the dlib library here. So we are going to take the shape predictor for 68 points. Okay, and we are going to create the object for the face detector, which is this one here, and we are going to uh, create the object for landmark detector using this weights model already pre-calculated. Okay, so first thing to do is just to read an image that we are going to take this one here. One thing that is different between OpenCV and dlib is that OpenCV use uh, BGR uh, depth for the images, whilst dlib uses RGB. So as we are loading the image using OpenCV, we need to convert from BGR to RGB, so the image can be used by the dlib library. Okay, so now we show this image, which is this girl on here. Okay, and we are going to calculate the landmarks. So landmarks is using the detector that we showed before, and this helper function it only identifies the points of the landmarks which are shown on here. So the the output of this method is just a list with a tuple or tuple of points for each of the points of the landmarks. So if you see, this is the uh, order of the landmarks that are detected by the dlib library. So you see here the uh, part of the face, the lips here, the nose, and the eyes and the eyes brown. Okay. Uh, okay. And we are going to apply or to show how these landmarks are detected in the image that we just loaded. So for that, we are going to use this simple method where we are going to draw a cycle for each point of the landmark. So basically, we take the original image and we introduce the landmarks points, and we just draw a cycle uh, in blue with this thickness. Okay, and remember that now the image is in RGB, so that's why the cycles will be in blue. Okay, and we just plot the image. So as you can see here, the library has already detected the hole, the lips, and the eyes and the nose. You can see here that well, we are going to have some issues or minor issues with the lips because this point here is not just in the border of the lip, so we will miss this part of the lip in this particular case. Okay, so first thing that we are going to do is to create functions, helper functions, just to identify the main parts of the face. Okay, so we are going to create this function just to identify the upper lip. Okay, so we are going to introduce the landmark points as we have already calculated before, and these are the points that correspond to the upper lip. Okay, these are 49 to 55. If we go here, it's 49 to 55, and then 65 to 61. Okay, and then back to 49. Okay, so then 65 to 61, and then back to 49. So we have a closed uh, polygon. Okay, and then what we select is these points from the landmarks detector from the points that we have just calculated. And remember that we have to subtract 1 because the first landmark is 1, whilst on Python the index of list starts with 0. Okay, so that's a minor issue, but it needs to be taken into account. And we will do the same for the lower lip, left eye, and right eye. Okay, so now we have these helper functions just to identify every part of the face that we want to identify. Okay, and we are going to create this function just to apply lipstick to the image. Okay, so the input will be an image, the landmarks, the lip color, and I have introduced here a boolean, a flag, just if just in case that we want to use this on a video or just on a static image. Okay, perhaps the is realistic function can be used also on a video, but it depends on the hardware where you are going to run. I'm going to explain the differences later on. Okay, so uh, so the next step or the first thing that we do in this function is just to create the list of points that corresponds to the upper lip, which is the function that we define over here, and the list of points that corresponds to the lower lip. Okay, then we create a polygon, okay, with these two lists. Okay, so we can use these polygons uh, on the OpenCV fill polygon function. Okay, so as you can see here, for the simple approach, when is realistic is false, we just fill the polygon defined by these two uh, arrays, and we fill it with color, lip color, okay, that we have introduced, and then we'll return the image. I have introduced here two images because I want to explain later on how I'm working with the mask. So that's the reason. That's the only reason why this function returns twice the same image. Okay, and in order just to have a general uh, way to zoom in the lips area, we are going to store the coordinates of the lips just to make that zoom. Uh, we will see it later. Okay, so now we apply this lipstick function. We create the color that will be an RGB color, and we call our function. Okay, and we plot the the uh, the image. So here we have the image with the new color for the lips, okay? And here we have a zoom the image. This zoom is coming from these coordinates here that we have defined on here. Okay, so as you can see, we have created this polygon. Well, one polygon for the upper lip and another polygon for the lower lip, and we just fill it with plain color. So you see that, well, this is not very nice when you do a zoom, but if you are in a movie, this is going to be very fast and you hardly see that on a normal image. Okay, if you want to do a more realistic coloring of the lips, we can use this flag. In the previous part, or in the previous section, this flag was set to false, and now we are going to use a realistic approach. Okay, and on a realistic approach, you see that we see uh, the reflections of the lights are on here, and we have a higher accuracy, and also is more realistic in the image, as you can see on here, the difference between the two. Okay, so how this realistic flag is working. Okay, and this is what we are going to explain on here. Okay, so the first thing to do is that we need to create a mask with the lips. Okay, so for that I have used the same function that I use in the non-realistic approach, where I fill a polygon, and I have created two images. One with no lips, where we have fill the lips with a 0 value, and another image where we have the lips with a white value. Okay, so if I show you, for instance, the uh, second image, let's check it on here. Okay, you see that here we have just the lips. Okay, the original lips. Okay, okay, so there's next thing that we do is just a subtraction between these lips, where these lips are sorry, this is not what I wanted to show before. Let me show you this better. Okay, I think this is right. Okay, I'm going to run this. Okay, and this is what I wanted to show you, that we have the image with the lips in white. Okay, and then what we do is just subtract. We subtract this image with the white lips to the original image, and well, and this operation will be already within the an 8-bit depth image. Okay, so this operation will be already between 0 and 25. Okay, but just to be sure, we use this NumPy clip option that clips any value that are above or below this range here. Okay, but as lips maximum value for lips is 255, and we subtract the original image, which is based where we base the lips image, that should be okay. But we do it uh, just to be sure that we are within the 8 bits. This can be deleted in case that we have problems, in case that we want to use this on a video and we have some delays. Okay, the next thing that I'm going to do is just to create a mask for the lips. So for that I convert this lips image into a gray image. Okay, and then I do a threshold of these lips. Okay, using a threshold binary for every value that we have above 1. Okay, so for that, if you see on here, I'm going to show you how this mask looks like. Okay, you see this is the mask that we are creating. So now we have everything fill in black, and we have only this part of the image in white. Okay, we have a single pixel here on black because probably we have that pixel on there, a black pixel on there. Okay, so now we have created this mask. Okay, uh, we are going to use this mask for uh, extracting the lips. Okay, on the previous lips function, let me show it on here. On the previous lips function, you see we have this. Okay, and this is because we are doing a subtraction. Okay, so this lips is just the subtraction of these two images, and hence it's not a realistic value color. Okay, because actually the color is 255 minus the original color, because we are subtracting 255 lips from the original image. Okay, so in order to uh, correct this, okay, we are going to do this calculation. Okay, so now we are going to introduce an array with this original value, uh, subtract the 255 from the lips, okay, and create a mask. Okay, and now if we show this mask, okay, you see that now we have the real colors on this image, and everything is black except the area where we want to work. Okay, so keep going. Now we introduce the color. Lip color is one of the input variables to our function. Okay, and we convert that into a numpy array, and we create another mask. This mask will be where this mask that we have created with only the lips, where the values are above 0, that means only the lips, we are going to add the values of the lips and the new color. Okay, and again we are going to clip this, because now we have a chance that if the lips, for instance, have already a value of 250 or 255, and we are adding some color above that, we overflow the unsigned integer 8 variable. So that means that we will start again from 0, and we will have some strange situations where we may have blacks or very strange colors because we have overflowed the variable. So now here it's really important just to keep this clip function. Okay, and for the points where the lip this condition is not met, we keep a value of 0. Okay, and now again we just do the summatory of the no lips image. If you remember, it was the image where we remove the lips, we put them to 0, and we add the new mask. Okay, again, this should be fine, so we don't need to clip this because already mask is within 255 and no lips is 0. Okay, but I keep it on here just for security. And in case that we are working with some decimals and force this array to be unsigned integer 8. Okay, and as a result of this, you see that we will have this image. I'm going just to return the same image again as before. Okay, and now you can see the image and a zoom of that image with the results, so, which is more realistic than this approach here. Okay, the second feature that we are going to introduce in this virtual makeup program is just to apply eyeliners. Okay, so here we are going to introduce the image, landmarks as before, the RGB color, and the thickness uh, of the eyeliners. Okay, as before, we calculate the list of points for the left and the right eye. We create a polygon uh, NumPy array. Okay, and we use this function on OpenCV. Is writing polylines for a copy of the original image, because this is a destructive function, so it will overwrite image otherwise. So we take a copy. It's the same as we did on here, that we need to work with copies because fill poly also overwrites the original image. Okay, we introduce a list with the two arrays. We force the polygons to be closed, just in case that we make a mistake in this definition of the landmarks. We always be sure that we started and close the arrays with the original value, but in case that we make a mistake, this is also a nice thing to have on here. Then the color will be the one that we have applied, and the thickness. Okay, and as we did before, just to do the zoom, and as we know the coordinates of the eyes in the image, we will get these points here, and you can see here the image with the eyeliners and a zoom on that. When you do a zoom, you see that this is really a polygon. Okay, but in normal image you will not see that. Okay, and we are going to apply everything, uh, the two things together, and you can see here the original image and the new image with the thickness and the lips. I'm going to change the thickness just to make it a little bit uh, uh, more thickness on the eyeliners, and I'm going to change also the color of the lipstick. Okay, let's see that. Okay, so you can see here that I have changed the colors to nearly pink or purple, and I have increased the thickness of the eyes. Okay, and I'm going to work this with other images. I have other images here just to show you that how it works with other images. Sorry, I'm going to run everything again. So it depends on the image and how the dlib library fits the face. We may have a better or worse approximation to the detection of the lips and how we feel the lips. We will see it on these examples here. Okay, so let me check if this has run. Okay, so now we have another image. I have changed the image. So now we have this image here. Okay, keep going. We detect the landmarks, and in this case, you see that the lips are very well detected and the eyes as well. So we are not going to have a problem with this image here. And we have the automatic detection of the lips based on these points that we identify here. Okay, and this is the simplistic methodology for the lips, and this is the more realistic one. Okay, and the same for the eyeliners. I have applied here a thickness of 3, and now we have the difference between these two. Okay, and finally we are going to use another one, and just for a final check, I'm going to use GEL0 and run again everything. and see the results for a different image. Okay, let's go to the beginning of the notebook. Okay, and now we have this face here. Okay, let's keep it going. The detection of the lips and eyes are fine. And first approach, a more realistic approach, although the color in this case is not very nice for this image. The eyes here, perhaps the thickness of 3 is too much for these eyes. It all depends on the size of the image. So this image is smaller, and hence a thickness of 3 makes this a little bit strange, okay, compared with the other uh, images. So here probably it's better just to do one, and here put in this reddish color, and probably this is slightly better than the other one. Okay, perhaps we can do something like that and rerun this just to check. Well, this color for the lips are much better, and now the eyes liner is also just better for this image. Okay, so this is my sample of project for virtual makeup, and there's more things that can be done, just like changing the color of the eyes or even changes the color of the hair, but we will do it that in another tutorial.